Hi friends, continuing our discussion on monostable multivibrators, let us see one more model of monostable multivibrator. In this case, the output is taken from the second stage instead of the first stage as we have done in the previous case, and we want a stable state to be zero. Therefore, we need a zero here with no disturbance, and if you want a 0 here, this has to be 1, and if this is to be 1 and capacitor should not be charged, then this also should be 1. So because this is 0, we get a 0 here, this keeps it 1, and this is 1, this is 1. Make sure the capacitor is uncharged, and this is okay, but only problem is if this is 1, and if you connect resistor to ground as we did previous case, then there will be current flowing, and that current will disturb the voltage across capacitor, and we don't want it to be disturbed under stable state. Therefore, make sure voltage across resistor is 0. Therefore, instead of connecting the other end of resistor to ground, connect it to VCC. Now what is happening is, under stable state, we want output to be 0. That means this should be 1. 1 means VCC, this end is VCC, this end is VCC. Therefore the voltage across resistor is 0, no current is flowing, and hence doesn't disturb the capacitor. 0 here, 0 here, 1 here, this is 1, 1. So that's stable state. And want to disturb it, yes, we need a switch here to disturb it, and for a moment, if the switch is pressed, then this voltage goes low, and because this voltage goes low, this also should go low, because voltage across capacitor cannot change instantaneously. If this goes low, this goes high, high comes back, and this high will make sure to be low. So a low coming from this output ensures no more pressing of the switch is required. But the problem now is this voltage has gone low, therefore current starts flowing, and this current will flow through the capacitor, and this charges the capacitor, and the voltage across capacitor rises exponentially, and after some time it is going to reach high, and the moment it reaches high, this output goes low, and this low comes back here, this makes this high, and this high suddenly from 0 to 1 it increases, therefore this also jumps up. But only problem now is this was already high, it is again making high. That means logically there won't be any problem, it is assumed to be high only, or one state, and hence this is going to be 1, then this is 0, this is 0, this is 1, then this had raised above VCC, but now the capacitor will get discharged, and because of which it comes down to VCC after some time, and that continues. So that's a stable state, this is a quasi stable state. So how this looks in the transistor version is what we need to look in our next session. So till then, take care, see you, bye.